identities that we absolutely must have memorized for the AP exam. Those are sine squared theta plus cosine squared theta equals 1, 1 plus tangent squared theta equals secant squared theta, and 1 plus cotangent squared theta equals cosecant squared theta. We are going to use these when solving various problems involving trigonometry throughout our course, but for right now we're just going to use that information to solve for x when 0 is less than or equal to x, which is less than 2 pi. So let's go through this first example here. We have 2 sine of x plus 1 is equal to 0. We want to solve for x, so I'm going to subtract 1 from both sides. I get 2 sine of x is equal to negative 1. I have sine of x is equal to negative 1/2. So we want to find that when is sine equal to negative 1/2? Well, we can revert back to our unit circle. I'm not going to draw the whole thing out, but we know what our unit circle looks like. And so we're going to have sine of x, well, it's going to be negative, so it has to be in our lower half of our circle here, and we're going to have that short distance, so it must be here and here. And we know that at this point and this point, we're going to have this is equal to 11 pi over 6, and this is equal to 7 pi over 6. So I kind of did those out of order, but here x can be equal to 7 pi over 6 or 11 pi over 6. Let's go through our second example here. We have secant squared of x minus 2 is equal to 0. So if I'm solving for x, then secant squared of x is equal to 2. I take the square root of both sides. So I get the secant of x is equal to radical 2, which is the same as saying that the cosine of x is equal to, and this should be a plus or minus if I'm taking the square root, cosine of x is equal to plus or minus radical 2 over 2, and that happens because I've inverted secant and I've inverted radical plus or minus radical 2. So cosine of x is equal to plus or minus radical 2 over 2. We know that cosine is going to be equal to radical 2 over 2 in these 4 areas. Therefore, x must be equal to pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Let's look at number 3. We have 3 tangent of 2x minus radical 3 is equal to 0. Well, I'm going to do 2 steps at once here, basically just to save space. But tangent of 2x is equal to radical 3 over 3. That makes sense there. But now we have that 2x is equal to tangent inverse of radical 3 over 3. So what's 2x going to be equal to? Well, 2x could be equal to pi over 6. 2x could be equal to, let's go back to our unit circle here. What's it? Radical 3 over 3. Well, it's going to be pi over 6 and 7 pi over 6. Oh, you can't see that in here, but so 2x could be equal to pi over 6, and 2x could be equal to 7 pi over 6. Now I need to divide both sides by 2, so this is actually going to be equal to, so x is going to be equal to pi over 12. And here I'm going to have that x is going to be equal to 7 pi over 12. Now, we were actually asked to find this between 0 and 2 pi. So if I do this, and I've gone like 2x, I need to go around this unit circle twice. So I also know that 2x could be equal to, 13 pi over 6. Let me erase that a little bit there. So 2x can be equal to 13 pi over 6. And again, x could be equal to 13 pi over 12. Or 2x could be equal to 19 pi over 6. And again, x could be equal to 19 pi over 12. So all we did to go around a second time, you can see here, looking through the difference, we added 12, which is just basically 2 pi, right? We added 12. That's basically 2 pi. And we did that because this 2x tells us we're going around twice. Let's go over here to number 4. It doesn't really look like I've left myself enough room, but I will try my best here. So I'm going to go 2x, 2 cosine squared x, cotangent x is equal to cotangent x. The first thing I want to do is get everything over to one side. So I have 2 cosine squared of x, cotangent x minus cotangent of x is equal to 0. I'm going to factor out a cotangent of x. So I get 2 cosine squared x minus 1 is equal to 0. Well, looking at this, I know that I can set up two things here. I can say that the cotangent of x is equal to 0 and that 2 cosine squared x minus 1 is equal to 0. If I have cotangent of x is equal to 0, well, then that means that this is going to be the tangent of x is basically going to be undefined, right? Because if I have 0 over 1 and I inverse that, it's going to be 1 over 0. So where's the tangent of x undefined? Well, the tangent of x is undefined when x is equal to pi over 2 or 3 pi over 2. 2 cosine squared of x minus 1, we can solve for that. So we're going to have cosine squared of x is equal to 1/2. I take the square root of both sides. I get the cosine of x is equal to plus or minus radical 2 over 2. I'm not going to go through that algebra there. When is cosine of x equal to plus or minus radical 2 over 2? Well, that happens when x is equal to pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So here you can see we have actually 6 answers for this problem. All right, let's do one final problem. Practice this. 2 sine squared of x minus 3 cosine of x minus 3, or plus 3 cosine of x minus 3 is equal to 0. Right now we don't have anything that we can combine or work together, but if we go back and look at our trig identities, we can actually use those to substitute in and kind of get things that are a little bit more cohesive. So I'm going to see here that the sine squared of theta is equal to 1 minus cosine squared of theta, and I'm going to substitute that. So I will rewrite this as 2 times 1 minus cosine squared of x plus 3 cosine of x minus 3 is equal to 0. And I distribute, so I get this. Then if I simplify, I'm going to have 2 cosine squared of x minus 3 cosine of x plus 1 is equal to 0. And here you can see that we basically can just factor this. So if I rewrite it here, I have 2 cosine of x minus 1, and I have cosine of x minus 1, and both of these are equal to 0. And then from there I could set these equal to 0 and solve for x. That's all there is to it, simplifying trig identities and evaluating trigonomic functions.